Shall I? So let us see what are the different types of physical quantities. Types of physical quantities. So there are two types of physical quantities. Fundamental quantities and derived quantities. Okay. So fundamental quantities are those quantities which do not depend upon any other physical quantity for their measurement. Right? So what are fundamental quantities? So first, second. Fundamental quantities are those quantities. When I say quantities, you understand it is physical quantity. And what is physical? Anything which can be measured. Okay, that's we call physical. Quantities which do not depend upon other physical quantities. That is, they are independent of other physical quantities for their measurement. Okay, so those quantities are called as fundamental quantities. Can I clean the board now? Yes. So units of fundamental quantities are called fundamental units. Right? So what are the examples of fundamental quantities? So there's length, mass, time. Okay. Then you have current, electric current. Temperature. Amount of substance. And you have luminous intensity. Okay, these are the examples of fundamental quantities. I'll explain each one of them. So, right now. So quantities, what are derived quantities? These are quantities which depend on units of other physical quantity for their measurement. Okay. So you cannot measure them independently. We'll see an example. So units of derived quantities are called as derived units. So, example. Speed plus speed. So many thousands of derived quantities.
Speed and velocity are the same.
No, speed is scalar. Whereas velocity is a vector quantity. So to describe speed, we don't need the information on direction. Whereas in velocity, you need information on direction also. Right? So it's a vector. All of them are vector. Like velocity, acceleration, force. So good thing is there are only 7 fundamental quantities. So you can easily remember those. And all the derived quantities are combination of those 7 fundamental quantities. In addition to those 7, there are 2 additional fundamental quantities which we call as plane angle and solid angle. So these are 2 more: plane angle and solid angle. I will explain what it means. So have you written down everything? Okay, so let us see it in some detail. Yes. Have you signed?
Yes.
Be careful of it. So I think leave 1.5 page. you are following this kind of a notebook, leave 1.5 page to write down on this part. So let us see what are the physical fundamental quantities and their SI units, symbol, SI unit, and then its symbol. Okay. So what is the first fundamental quantity? Length. When SI unit of length is also meter. So the full form of all the units are written in lowercase. Okay, and the symbol is just M. So you would say it was M in metric system also, and this is M in SI case also, right? So basically, who decides these units and symbols, right? So there is Bureau, BEARO, just check the spelling. Bureau of Weights and Measures. See, every country has Bureau of Weights and Measures. Okay, who has the responsibility to decide about units of physical quantities, right? Now, there should be consistency in units, like 1 meter in India should also be 1 meter in UK or US, right? So Bureau of Weights and Measures of all countries, they generally meet together, okay? And the last discussion they had was in France at a place called Cedars, near Paris, okay? Here they decided what should be the unit of measurement for every physical quantity, being the fundamental physical quantity. Okay, so what they have decided is for length, all countries should use the standard international system of units. Decided that for length, all countries will use meter as the unit. Is that clear? Okay. So that's why you see some repetition. But now it is standardized. Everybody is using SI system. Okay, so no confusion. And for mass, everybody is using kilogram. So K is lowercase. You have to remember that whenever you are writing the full form of the unit, you have to write it in lowercase. And the symbol also has kg. Third is time. So the SI unit of time is second. And the symbol is S. Fourth. So electric current or temperature, let us say temperature. Any idea what is unit of temperature? Kelvin. Kelvin. The SI unit is Kelvin. And the symbol is capital K. So what is the rule here? Whenever the unit is named after a scientist's name, then the symbol has capital letter. Okay, but the full form has all lowercase letters only. There's the rule. Okay. Then fifth, electric current. What is electric current unit? It's ampere. Okay, and the symbol is A. Right? 6. Amount of substance. Its SI unit is mole. Right? And its symbol is MOL. Any idea what is mole? Heard about it before? This is the first time hearing about it. So write it down. Seventh is luminous intensity. This is candela. The symbol is CD. Right. Then the fifth is plane angle. Plane angle is measured in radian. Symbol is RD. Then you have solid angle. And it is steradian. This is the steradian. So these are the only units that you have to memorize. All the derived units are basically combination of these. Okay? No units outside this. So now these things are straightforward, right? Everybody has decided what length is 1 meter, how much weight is 1 kg, right? So all these things are decided by the Bureau of Weights and Measures conference in Paris. So you can see in your book it is given, right? Like what is 1 kg? It was a weight of a platinum iridium alloy. Okay, so one block of platinum iridium alloy, they agreed that we will call this as 1 kg, right? So then every country got a replica of it. Everybody called that as 1 kg. And then various like repetitions of that was made, like every shop has a 1 kg block, right? So it has to be mapped onto this, okay, by comparison. So that was called 1 kg. Like a meter scale was also a platinum iridium rod with some marking on it. right? So this marking was called as 0 and this was called as 100 centimeter. It was divided into 1000 equal part, the smallest part being 1 millimeter. So it is kept there in Paris, right? But these are very old standards, right? Units should be fixed. So basically, it has been found that when temperature, etc., the length increases or decreases, right? So unit should be chosen in such a way that it is independent of ambient conditions, right? So now there is a different standard of length, right? So it is the distance traveled by light. So just open your books. You have textbooks on page 3. So as the understanding evolves, we settle for different standards of measurements. So today, so initially meter was this. Okay. Like meter was originally defined in 1889 as the distance between two marks drawn on a platinum iridium rod kept at 0 degrees Celsius in the International Bureau of Weights and Measures at Sevres near Paris. So that we called as 1 length. Then every country had a similar rod and they called it as 1 meter. Okay. But in 1983, another conference happened. Now see how did they decide about the meter then? The meter was redefined in terms of speed of light. Okay. According to which 1 meter is the distance traveled by light in 1 divided by a very big number. It's a very small part of the second, right? Of a second in air. Now, does it make sense to you? What does it mean? Just read everybody and then see if it makes sense to you. What is the unit of light? You are not expected to memorize these definitions because it is difficult. Okay, there won't be any questions also. Even in notes, they have not mentioned about it. So questions are not expected on that. But at least read it once so that you understand. Does anyone know what is the speed of light? 3 into 10 raised to 8 meters per second. So what does it mean? It means 5. So 10 raised to 5 is 1 lakh. Right? So what does it mean? That in 1 second, light can travel 3000 lakh meters. Light has traveled 3000 lakh meters, not 1 lakh. 1 lakh, 3000 times. That much light travels in just 1 second. Can you imagine how long that distance would be? Okay. So in a second, so light is the fastest physical entity to travel. There is no physical entity which can travel faster than light. Okay. So then what is meter? Meter is the distance traveled by light in which part of the second? Give me the number. 299 792 458. Now this is a number close to almost. So it is this number only, right? 1, 2, 3, 4, 5, 6, 7, 8. It's like 3000. So one part of this. So you make 1 second, which is this. Okay, you make these many partitions of that second, and in one partition of that, whatever distance light travels is 1 meter. So it would be slightly like overwhelming to visualize right now, but I'm just explaining this. Like, what is the standard for 1 meter? Now, why we have taken speed of light as a reference for 1 meter? Because it is independent of any temperature condition, anything, it will not change. Speed of light remains 3 into 10 raised to 8 meter per second in all conditions. Okay. Likewise, we have unit for kilogram. So let's see what is the unit for kilogram. Unit for kilogram is, okay, so on page 4 in the new book, again it was decided in 1889 that 1 kilogram was defined as the mass of a cylindrical piece of platinum iridium alloy kept at International Bureau of Weights and Measures at Sewers, Netherlands. So they called that block as 1 kg. But now it is not followed. Now it is defined in terms of Planck's constant, so which you will understand in higher standard. Okay. So it's not expected of you to remember all this. So there no question will be asked. Right. So likewise for second also, second is in terms of the number of duration, which time duration we call as 1 second. So in old times we used to call, like, you know that Earth takes how many? 24 hours, right? For 1 hour. So that since we already know. So what we call is time between one sunrise to the next sunrise. We call that as 24 hours. So whatever number you get, one part of that is 1 second. Okay. So how much is this? 186. 24 into 3600. How much is this? One second. 86400. 86400. So 1 by 86400 watt of mean solar day. So you need not write all this. I'm just telling you, you can read it in your book. Okay, once you read it and just leave it, right? So this is we have discussed 3 units: the meter, kilogram, and second. So what is second? Second is 1 by 86,400 part of mean solar day. That duration. So what is mean solar day? Time or duration between one sunrise to the next sunrise. And why mean solar? Because it is not same throughout the year. So every 365 days, you whatever duration you get, right? Mean of that is mean solar day. Okay. And then of that mean solar day, you take this fraction. So that fraction we are calling as 1 second. That was old unit of second. Today we follow in terms of atomic clock, right? So there is a cesium 133. Okay, so the atomic clock based on this. So what it does is, in the 2 level, there is concept of energy level. Again, this you will get in higher classes, right? So from these energy levels, some radiations are emitted. Okay. So this is called one vibration, one peak, and okay, it is called crest and trough. So this is called one wave or one vibration. So how many number of vibrations? So durations, time duration, for one vibration, some time will be needed, right? So there are some 9192 631 770. These many vibrations. So whatever time it takes to produce these many vibrations by this atom, that duration we are calling 1 second. Okay. I cannot remember it. Okay, there could be some student who practice very hard and remember, but that is not expected. You're not expected to memorize. I'm telling it again and again just to make you comfortable. Okay. But hope you're understanding what is the standard of time, what is the standard of length, what is the standard? Standard means unit. How did we decide what is 1 meter? How did we decide what is 1 meter? How did we decide what is 1 second? Okay. All right. So I think this is all about basis of unit. Now we'll go ahead in understanding what is amount of substance, right? I think till here you are clear. Till 5 minutes you are clear, I guess. What is amount of substance? Now, when you say, when we are dealing with atoms, right? Now, this could have some weight in terms of grams, like mass in gram, like let's say it is 50 grams. So I can visualize what is 50 grams. 50 times 1000 part of a kg is 50 grams, right? But how do we describe the mass of atom? So one atom will have such a small mass that talking about mass of atom in terms of kg will be ridiculous. Okay. So at atomic level, we talk about mole. Right? So what is mole? Mole is a number. It's 6.022 into 10 raised to 23. This number is called 1 mole. Just like 12, a group of 12 is called 1 dozen. Right? So these many number of atoms or molecules are called 1 mole of atoms. Right? So if we take 1 mole of hydrogen, right? So what is the atomic mass of hydrogen? 1. Atomic mass of hydrogen is 1. 1 what? 1 U. 1 U, atomic mass unit. Atomic mass of hydrogen is 1 U. But when we take atomic mass of 1 mole of hydrogen, that means these many number of hydrogen, it will become 1 gram. Okay, if I take so many, so any element if I take a mole of an element, its mass becomes, instead of U, it is converted into gram. Because now I am considering so many hydrogen atoms, not just one. So this is a relatable unit. We understand gram. Understood? So if we have a container in which some gas, hydrogen gas is filled, so it will have billions of atoms. Like in our LPG cylinder, it weighs around 40 kg. But what it has is a liquefied natural gas, right? So when we talk about atoms, we always talk about moles, a group of atoms, not individual atoms. Okay. Now, what is luminous intensity? So there has to be a way to basically differentiate between a bright light, a dim light, right? So those light intensities are measured in terms of candela. Okay, so it's a unit of light. So for example, if the luminous intensity produced by 1 tube light is 1 candela, so if I have 2, I will say 2, 3 candela. Okay, so you will understand it when you use it, but we will not be using it in 11, 12 standard. Okay? So you won't be coming across. It's only in higher standard. Now, what about plane angle and solid angle? Let me explain. Can I erase the board? Just one. I think you have written it down. See, plane angle is is 2D angle, angle in 2 dimensions. 2D angle, like circle. So in a circle, if an object is traveling in circle, let us say it goes from point A to point B, then so AB, the arc inscribes angle theta, let us say. So this angle in 2 dimensions is called plane angle. What about, so when it covers this full circle, we say it is 2 pi radians. Right? Whole circle is 2 pi radians. So pi radians or RD is equal to 360 degree. This you are familiar, right? Are you familiar with degrees? So full circle is 360 degree, and this is the relation between radian and degree, right? So pi radian will be 180 degree, right? 360 divided by 2. Okay, this is the relation. Now, what is solid angle? Solid angle is angle in 3 dimensions. Solid angle is 3D angle, 3-dimensional angle. Can you give me an example of 3D? Sphere, correct. So, did you say sphere? Yeah. So, if you have a sphere like Earth, any planet, right? So, any sphere like a football, okay? So, this is Earth. So, if I draw a circle on its surface, right? Then it will inscribe a cone at the center. Cone, it will make a cone, right? So then this angle, okay, this angle is the solid angle, right? So it's a 3D angle. Okay, so 3D angle is measured in terms of stereo. So just for your understanding, what is plane angle and what is solid angle. Okay. More details in 11 or 12 standard, not now. Okay. So any questions so far? No. So you missed just one page wherein I had started with defining what is measurement, what is unit. Okay. So you can just copy it from your peers. Just take a snap of that and write it. What? What is the fundamental issues? Yes. Okay, so I think I have covered quite extensively what are fundamental quantities, what are their units, what units mean, what is the basis of this, and everything else. So you can read yourself. If you have any questions, you can ask anything. So let us proceed. I think we still have 5 minutes. How much more time we have? We have 5 minutes, right? Class is still
5:15.
5:15. Yes. Okay, now there are some rules about choosing units. Okay, so choice of units. So how should we choose units? Like these guys, Bureau of Weights and Measurement, when they meet and decide about units, what do they discuss? They discuss that the unit chosen should be convenient. Convenient. Right? So meter scale is convenient. Anybody can use it. Right? Second, it should be easily reproducible. So once the prototype or standard is decided, it should be easy to copy and reproduce it so that others can also have them and use it. Right? Third, it should not change with place and weather. Not change, because once the unit is decided, it should remain constant or fixed. It should be independent of place and weather. Right? Like in winter, it should not contract. In summer, it should not expand. So once decided, it should remain fixed. Okay? So it should remain standard. 4. It should not be ambiguous. Not be ambiguous. Ambiguous means, like if I give you a scale, suppose 0 mark is missing, or some marks in between are missing. So it will be confusing, right? So it should not be ambiguous. It should be very clear. Okay? So that everybody can use it. So these are the various choices of units. Right? Okay. I think this is all. We'll stop here for today. So any questions? Questions from earlier questions? Good. Just look at the notes. This is a very, very fundamental chapter. I know it's a little heavy, so don't worry. Next is experimentation on that. So we will start with vernier calipers, screw gauge. So in experimentation, we'll see how to use those instruments to measure length. Now, to measure a normal length using a scale is very easy, right? But if I ask you what is the thickness of the hair, can you measure it with scale? Conventional scale, right? So there you will take help of screw gauge or vernier. So measuring very small length, measuring large length. How will you measure very large length? Can you do it physically? So length between say Earth and Moon or height of Everest, right? So those are not direct measurements. Even if you have scale, but you can't really measure it. So we have some bigger units of length, like astronomical unit, right? When you read, so go home and read. It's very interesting. So there are some bigger units of length, bigger units of. Such as astronomical unit. Any idea what is astronomical unit? And then you have small unit of length. Right? So this is, I think, in terms of 10 raised to 13. It is of the order of 10 raised to 13 meters. Just check what is that? 13 or 11? I'm not able to see. It's 10 raised to 11, 1.496. So it is a very big unit, right? And you have small units such as angstrom unit. So this is angstrom. And this is astronomical unit. So big unit of length, small unit of length. What is astronomical unit? Do you read science fiction novel or you watch TV program which are based on science? So astronomical unit is nothing but the distance between Earth and Sun. Right? So Earth revolves around Sun, right? So this distance goes on changing. 365. So the average distance between Earth and Sun, that's called astronomical unit. And it's about this much. Okay. What is angstrom? It is a length corresponding to 10 raised to minus 10 meter. So it is like which part of a meter? Very big part of it. Right? Lakh part of a meter is 10 raised to minus 10. Now what is angstrom? It is the radius of an atom, say hydrogen. Right? So if you have a hydrogen molecule, so its radius of hydrogen molecule will be on the order of 1 angstrom. So at an atomic scale, we talk about such smaller length. When you go to nuclear scale, even smaller length, 10 raised to minus 15. It's called Fermi. Okay. So it would be interesting with this background. I think now when you read the chapter, okay, so just become familiar with the terms. You don't have to memorize it. So read it with free mind. Don't become heavy. Okay, right? Because these things are new for you, so and you'll get used to it. All right. I'll see you in the next class. Thank you.